We're doing exponential growth and decay, which is technically an Algebra 1 concept, but we're going to step it up just a little bit for Algebra 2. So let's get started. Exponential functions look like this. That's a function equals a times b to the power of x. The key here is that x is the power. It's not 2, it's not 7, it's not 300. That was last trimester. Now the power is x, so that's the thing that we don't know. Let me show you what happens when a and b change. Okay, so below me I have a graph. This is an exponential function. This is an exponential function where a is 1 and b is 2, and you can tell that on the left side right here. So I'm just going to press play by a and just see what happens when a changes. Okay, ready? Okay, so when a is about a half, it's here at a half. Actually, can I do a point where it's at a0? Nope, 0a. I can do math. Okay, so I'm just going to press play again. So that went down. Hold on. There it is. Okay, so whatever a is the y-intercept. So when y equals mx plus b, that would usually be the plus b part. Here it's a. Don't get confused. So a changes the y-intercept. So a is our y-intercept. Okay, great. Let me put a back to being 1 so I can show you what b does. So b, watch what happens when b changes. Okay, notice that this is still at 1. Oh, it's at 0.8. There we go. Notice that a is still at 1. So what's happening when b changes? Okay, well, it's going, hold up, I'm not ready for negatives yet. There we go. Okay, so as b gets bigger, it gets more stretched out this way. What's happening is that right now, I'm taking every y value and I'm doubling it because it's times 2. It's times 2.01, but I'm going to double it. So here it's at 1 high. So here it's at 2 high. Here it's at 3 high. Sorry, at 4 high, and then at 8 high, and then it'll be at 16 high. So that height is doubling. So it got bigger. Okay, and then when it was a fraction or less than 1, it switched to going downwards to where it's flat on the right-hand side over here. Let me change this really quick so that way it doesn't go past 0. Because that gets weird. Okay. So b is bigger, it goes higher up, it gets stretched out. When b is a fraction, it goes the other way. It's only there for a little bit because it's like between 1 and 2, basically. Let's do that. Okay. Upright, left side up, right side up, left side up. It's like it's exercising, you know, like it's my yoga for the day is this graph. Okay, so let's talk about that over here. So B is the growth factor. But that's only when B is more than 1. When B is between 0 and 1, it's the decay factor. And how we write that is we say that 0 is less than B, which is less than 1. This just says that B is between 0 and 1. Okay, when it's negative, it gets weird because sometimes it works and sometimes it doesn't. But we'll talk about all the transformations in a second. But that's what's happening right now is that it's getting bigger or smaller. So the growth graphs are flat on the left and then go up. And the decay graphs come down and then are flat on the right. So that's the difference between a growth and a decay. Okay, let's practice this. All right, so we're going to graph y equals 2 times 1.5 to the x so I can show you how this works. So I already know my y-intercept is 2, so let me just do a little boop boop. Okay, so there's my y-intercept. And then every y value, I'm going to multiply by 1.5. Okay, so we're going to start with 0 for x, and that's at 2. And then I'm going to multiply this by 1.5 to get the next number. 2 times 1.5 is 3. So then my next one will be at 3. And then 3 times 1.5 is going to be, I almost said 7.5. I'm glad I checked my work, is 4.5. So my next one up is going to be at 4.5. And then if I do one more, multiply that times 1.5. That's going to be whatever 4.5 times 1.5 is. 6.75, obvi. That's going to go off my graph. 1, 2, 3, 4, 5, 6. So that's like here. Oh no. It's fine. All right, so it's going to curve up, and then over here it's going to keep getting flatter and flatter. This line that it gets flatter and flatter against is called an asymptote. It'll never cross the x-axis. Until next time. Next time we're going to talk about shifting it up and down where the asymptote changes. But right now, this line is called an asymptote. All right. Now, when we talk about graphs, we have to talk about the properties of the graphs too, right? So this one, we're going to talk about domain and range. Domain is the x values. All right, I can plug in any x into here, right? I can plug in positive x's, it'll go up. I can plug in negative x's, it'll come down. But either way, no matter if I even plug in a million, I'll still get a number out. So what we say is that x is all real numbers, or the shortcut version of that is that x is an element of the real number system. We've done this before. I just wanted to remind you, or if you were in a different class, maybe you don't remember, you didn't learn this or something. But x is all real numbers is what that says. The range are the y values. Now, there are no y values down here, right? Like the graph is all above the x-axis. There's no y values down here. So in this case, y is greater than 0. The asymptote. It's not equal to 0. This graph will never touch this line. It'll get really freaking close. Let me show you that picture again. Hold on. That graph, I mean. Okay. I can come over here. It'll look like it's touching, right? But if I zoom in enough, it'll be above the line. I can't get close enough, can I? I want to... Okay, I went too far out. But do you see how it's a little bit above? It's not exactly on. Okay, maybe I can't prove this to you. Oh, there it is. Okay, okay. See how it's doing that? It's kissing it. It's like, they're like electrons. They can't touch. Okay, so there's this little tiny gap that you can't actually see when we zoom out. Right? It looks like it's all touching. It's not. There's a little tiny gap. So it's not equal to, it's just greater than the asymptote. Okay, some of you missed out on financial algebra because you're here instead, which is great. I think you learn more here than in financial algebra, and financial algebra is not really stuff that you need to know it, absolutely, but I teach it to you anyways. So here's one of the things at financial algebra that you're kind of missing out on that we're going to do today, because this has a variable as the power, okay? So this is about money, usually, population as well. So here's what all these letters stand for. Hold up. Okay, I accidentally did N instead of D. Normally we do N's in case it like happens more than one time a year, if it's every quarter or something like that. But we're not doing that because it's a pandemic, so we're not learning that much. But A is the ending amount after T amount of time. So this is how much I end with. P is the starting amount. I know that A made sense as the ending amount, but P, what's P? P is called the principal. Okay, not like principal like Dr. Wadawa. Principal like in finances, I don't know. R is the rate. It's usually, it was a percentage and you turn it into a decimal. And then T is the amount of time that is in the account or that this thing is happening or whatever. So, okay. So how much money will I have if I invest $500 in the stock for 5 years at 2% return on investment? That might be wrong. I'm not actually a financial advisor, but I can do the math. So let's figure it out. Well, I don't know A, but this is the amount that I'm starting with. That's P. 5 is time. And then my R will be 0.02 because I take 2% and I divide it by 100 because it's percent. It's fine. Don't worry about it. Okay, so I'm going to take, I don't know A. So I'm going to take $500. Okay, now it's not 1 plus and minus like it was in the olden days. I am gaining money, so I'm going to use the plus. If I was losing money, I would use the minus. I'm gaining money though. I'm investing money. 2%, 0.02 to the power of 5. Let's figure it out. I don't know. Let me see. I should actually show you what I'm doing. I can just type this all in the calculator, but if you want to do it step by step, I do the addition first because it's PEMDAS. I'm doing parentheses first. And then I'm doing exponents after that. So power 5 of that. And I just round it. There's a bunch of zeros after this. I just round it to the, like, I usually do like 2 or 3. And I went to 3 because it's a 4 here and not a 0. Anyways. And then I multiply that by 500. Okay. So 552.04. So basically what happened was I gained $52. My total that I cash out is $552 because I put the 500 in there. By the way, that's why we do the 1, because the 1 is the original 500 and then the 0.02 is the amount that I had at the end of it. But I have to do the whole thing. So I'd make $52. That's pretty good. Maybe I'll do that. 5 years though, I probably can find a better stock. Okay, hope this helped. I'll see you in the next one.